If you have ever had to do an offline evaluation of a recommender system, you've probably used the DCG metric, which takes a cumulative sum of item relevance at different positions, discounted by the exposure that items actually get at those positions. And if you've used DCG, you would probably also know that the normalized variant is actually far more common, where we additionally divide by the DCG that some ideal ranker would obtain. The main question that we ask in this work is why? And the short answer is that the metric finds its roots in information retrieval, but evaluation settings that we deal with in real-world recommendation systems are typically different. And so the question becomes, well, when does normalized DCG actually estimate online performance? Now, it turns out if you make some assumptions about user behavior and certain independence of random variables, we can actually write them down and derive DCG as a statistical estimator for an online metric. The paper has much more detail on this. But that's great. DCG can be framed as an unbiased off-policy estimator for an online reward metric, and this should serve as a strong motivation in favor of the metric. The catch is you do have to use it right, which is not the very common form DCG occurs in the very first slide that I showed. Specifically, we need to get a model of exposure probabilities and then use those to re-weight observed rewards. So can we say the same thing about NDCG? Well, the answer is no, for the simple reason that a relative order between models as obtained via DCG is not guaranteed to be retained when you're using normalized DCG instead. As such, normalizing the metric is an inconsistent operation, and we should only consider it when we have good reasons to do so. Of course, the paper has extensive experiments as well, including promising results that highlight strong correlations with live A/B testing results. That's us. I'd be happy to answer any questions you might have, and we hope to see you at KDD.